Hi, my name is Kim Onunanya, and this is my Lines of Charges lab. So, to introduce you to the lab, an electric force is the attraction or repelling force between two charged objects or particles. These may be negative, positive, or neutral. An electric force is caused by the electric field generated from that object and is dependent on not only the charges but the distance from the observational spot. The models used in this lab includes Coulomb's law, electric force, and gravitational force. Coulomb's law and electric force are clearly relevant due to calculating the charges, and gravitational force assists us because the tapes moved away from each other in the y direction. These formulas assisted in the purpose of the lab, which is generating a computational model of two charged tapes and using this model to estimate the magnitude each tape exerts on each other. The main results are the charge on one piece of tape is 5.6 times 10 to the negative 9. The gravitational force is negative 9.8. The magnitude of the electric force is 1.4 times 10 to the negative 4, and the magnitude of the gravitational force is 9.8. So the models used in the lab is electric force, gravitational force, law of attraction, law of repulsion, and you can see them on the right. And some assumptions are that both pieces of tape are equal in charge magnitude due to their size and length. And another assumption is that there is no air resistance. So this lab is purely computational. There was no physical experiment. However, the conditions are still from the previous lab. The system is the two tapes creating an electric charge field on each other, and the surroundings consists of this free space that now contains those charges. And the initial conditions are the tape's mass, which is 0.002 kilograms, the width, which is zero point zero 0.01 meters, the length is 0.2 meters, the force of gravity, which we all know is 9.8, and the distance between the two tapes is 0.017 meters. So this is my code. I basically combined the code from the last lab and lab 0 while still using new information such as the distribution of charge. So as you can see with PES, that's the regular 1 over 4 pi epsilon 0 constant, the constant of gravity, the mass, and the charge Q. That's actually the charge that I generated from the last lab. And so to generate the electric field, I basically used the formula that I stated earlier. So basically, you need the charge, you need the R, which is the distance from the observation location and the particle. You also need the magnitude of R and the position vector. And basically, you plug that into the electric charge formula that I stated earlier. So for the discussion, the first two bulletins are actually from the previous lab. The observed charge was using the formulas, using like the math formulas, and I got 4.8 times 10 to the negative 9. And the computational charge was using the code from last lab, which is 5.6 times 10 to the negative 9. I added these because later on we will compare this computational charge to the one I got in this lab. And as you can see, the magnitude of the electric force is 1.48 times 10 to the negative 4, and the magnitude of the gravitational force is 9.8 times 10 to the negative 4. So my computational model was 5.6 times 10 to the negative 9 from the last lab, and this lab's model was 1.4 times 10 to the negative 4. As you can see, they're very different, so I'm guessing I had a bunch of error, whether it was due to rounding error with the meter stick or assumptions in the model, such as the assumption that the charges are equal in magnitude and distribution. So to answer the what if question, as I stated previously, those are my two model calculations and they are very different. This is likely because this lab's model is more accurate because it actually takes into account that the force will be a distribution rather than a point charge. So to answer the why question, the estimates differ because an electric field is dependent on an object's area, If we assume that the object is a point charge, that will affect the value because a point charge has a different area versus if we look at it as a long piece of tape that has a larger area.